Hey you guys, this is Mr. Sal. We're going to look at a question that a student asked about how to compare fractions using common denominators. These comparisons will be made with these inequality type statements like less than, greater than, or even equal to. So to do this, let's just look real quick at some basis for this. So for example, if you had a common fraction like 1/3, right? What we could do is we could scale this up without changing the value of it. What I mean is I could make this 2/6. It has the same value as 1/3, but I've scaled the numbers up. Or I've changed the denominator. We could even say that, right? Or I could say that it's the same as 3/9 or 4/12. Now again, all four of these are equal. The only difference is that we've scaled some of the values to look different. Now the reason why we would want to do this is because when we're comparing two fractions, we want to compare the denominators so that they are the same. And that way we're comparing the same size pieces. So for example, if I wanted to compare something like this one, we'll say this is 1/5 right here, right? But let's say that we wanted to compare this other shape, which is in sixths, and I had one of those sixths, right? So this red would be one piece out of 5, and the green would be 1 out of 6. So we're comparing these. What we want to do is make these the same size pieces. Now, that's not really looking at the accuracy of my drawing, so be careful on that. I mean, don't worry about how the drawing looks. To make these the same size pieces, we've got to, or we could, and this would be one technique to find the same denominators without changing the values, is we can multiply, for example, the 5 by 6, and then the 1 by 6 as well. Why 6 specifically? Because it's the denominator of the other fraction. Now, if I were to do this in this example, I would have to split the shape up this way into sixths. Well, now the red, it's out of 30 pieces. If we look at that, it's 5 by 6 right here. But how many of those pieces are shaded in? Right now there's 6 of them. Now again, notice the 6 out of 30 does not change the value 1/5. They have the same exact value, which is why I can put an equal sign here. We're going to do the same thing with the other shape, but it's already in sixths. What I'm going to do is split it into fifths horizontally this way. So now, again, if you were to count, you would see that there are 30 squares or cubes or slices, pieces, whatever. The green, though, right here, shows that there are 5 of those pieces. Now, again, we've shown the math right here to show why it's 5 over 30, but we can also show this using this model. So when we compare, or if we were to compare 1/5 with 1/6, once we get the same size pieces, 6/30ths is more than 5/30ths, which means that the 1/5 is greater than the 1/6. Now that's using a model, right? What I want to do is compare this one without using a model, such as 9/16 with 1/2. So if I were to compare 9/16 with 1/2, we can do this strictly with the math, right? And there's another way to do it, and that's using the least common multiple. So what I would do is I'm looking for the least common multiple of the denominators specifically. So I've got 16. Now, whether you know 16 is a multiple of 2 or not, doesn't matter. You can say that's 16 times 1, 16 times 2 would be 32. 16 times 3 would be, what is that, 48? And then 16 times 4 is 64. We've gone way too far, and we'll show why here in a moment, because the other denominator, 2, we need to find its multiples. 2, 4, 6, 8, 10, 12, 14, 16. Just right there we have the common denominator of 16. Well, what that means is the 9/16 does not need to change, but the 1/2 we will change. And the question is, how do I make that 1/2 into 16ths? Now some of you guys could do this in your head, but I can see that it's the 8th multiple of 2. So in other words, 16 is 2 times 8. So if 2 times 8 is 16, again, we don't want to change the value of the fraction, so I've got to take 1 and multiply it by 8 as well. So that would be 8/16. Well, in terms of 16ths, 9 is bigger than 8, or 9 is more than 8. So this one, if we went back to the original problem, 9/16 is greater than 1/2. Let's look at another example just to emphasize this. And we'll compare 1/2 just because we're kind of familiar with it, right? Now I'm going to use the same method that I did on the first one without the model. What I want to do on this one, to get the same size pieces in a model, all I've got to do is take the denominator from one fraction and multiply it by the numerator and denominator in the other fraction. So that's 4 times 2 and 9 times 2. That gives us 8/18. Again, that has the same value as 4/9, but I've changed the denominator. I've got to do it with the other fraction as well. So the 9, which is the denominator of this first fraction, I'm going to multiply it by the numerator and denominator of the other fraction. So 1 times 9 is 9. 2 times 9 is 18. I guess we kind of saw that already, but with 16ths. So again, in 18ths, 9 is more than 18, or in other words, 8/18 is less than 9/18. Now, is 18 the lowest common denominator? It is for this case, but it doesn't have to be because we're just comparing these values. So by doing this method, you'll find a common denominator every time, and you don't have to worry about finding the least common multiple, right? We don't need that list like we did in that last example. So that's a couple examples. I hope that's enough to get you guys started. Again, it's just comparing fractions without using decimals. We're just keeping the fractions using common denominators. Thanks for watching, you guys. I hope it helped. If it did, like the video, make a comment below, and subscribe to the channel. We'll see you guys in the next one.